Hey, welcome to our notes 1.6 continuity of trig, exponential, and inverse functions. So some of our trig functions are continuous everywhere, for example, cosine. So since I'm doing the limit of a continuous function, I can find cosine of my limit because cosine is a continuous function everywhere. So we can find the limit of the inner function and do the composition of that into the outer function. So as I start to investigate that limit as x approaches 1, I get an indeterminate form, 0 over 0. So therefore, I would start to manipulate that rational function by factoring the numerator to be x plus 1, x minus 1. So I cancel out that whole to leave x plus 1. So then the limit as x approaches 1 of x plus 1 is 2. So my final answer would be cosine of 2. And that's my exact answer. I don't really need to get a decimal approximation of that. So now where is this function, f of x, continuous? So we need to look at this as a composition of functions and think of the domains that would restrict this rational expression. So first let's look at tangent inverse. So in tangent inverse, if we think about the graph, it's continuous everywhere. So this is always continuous. If I look at ln x, it is continuous for x greater than 0. And for my denominator, I know x cannot equal positive or negative 2. So if I look at the composition of these possible domains, I know that x needs to be greater than 0 and it cannot equal positive or negative 2. So that would be, it is f of x is continuous on the intervals from 0 to 2 and 2 to infinity. So we somewhat think about domain restrictions at the same time as we think of continuity. So let's continue on as we investigate the squeeze theorem and some of its applications.